In this video, I want to show you how to make an amplified ultrasonic sound system. For this tutorial, you will need a 12-volt power supply, general electronic tools, a soldering iron, as well as flux and solder, a tweeter speaker capable of ultrasonic frequencies, an amplifier also capable of ultrasonic frequencies, an ultrasonic frequency generator, some signal wires to connect the frequency generator to the amplifier, and some speaker wire to connect the speaker to the amplifier. Also possibly needed are some resistors. For the first step, I'm going to take the outputs of the power supply and plug them into the inputs of the amplifier. Make sure do not get the grounds and the positive 12 volt mixed up. So black is ground, yellow is typically the 12 volts. So I'm going to get the ground and plug it into the ground right here. G and D is ground. So all you do is loosen the screw, insert these on each side of the screw. You might need to wind these up so there aren't any stray wires sticking out. You don't want any sparks or anything. So stick this under this big flat washer, then tighten it down. Do the same thing for the 12 volt side. Next, I'm going to get the speaker wire and connect it to the outputs of the amplifier. These are right here. I'm not going to do a bridged setup, so I'm only going to use one of the channel outputs. So I have a positive and negative right here, and this is a positive and negative for the other channel. So I'm going to only use this side. Next up, I'm going to take the other end of the speaker wire and attach some banana jacks. So I'm going to make sure and keep in mind which side is positive and which is negative, even though in this case it does not matter for the frequency generator since there really is no positive and negative. So to do this, I'm going to find the positive right here. I'm going to trace that wire. You also know there are different color codes. So this is the silver wire. So on the silver side right here, I'm going to put the red one. So red for positive, black for negative. So to attach these, you could just wrap the wire around, wrap it around clockwise so that when you tighten the nut, it'll be self-tightening. It won't unwrap the wire. You don't want to go too tight on this because these are really small studs, so they can strip. But it needs to be fairly secure. Once the first nut is secure, tighten up the next one. This is just a locking nut to make sure it stays torqued down. Pinch right here on the first nut and then tighten the second nut against it. So this will put P-tension on the threads so that neither of these will be able to untorque themselves. So do this for the negative side as well. Next up, I'm going to get the speakers that I've already made. I'm going to plug one set of wires into the back. Again, these are still color coded. It doesn't matter, but I just like to keep them consistent. So I'm going to put the red in the red and the black in the black. Then I have the other ends. I'm just going to plug them into the jacks here. Then you can put this aside for now. Next up, I'm going to connect the power to the frequency generator. So you could use the existing power supply. You could just run wires from here to here. But just for clarity, I'm going to use a separate power supply since you might be using one. So to do this, I'm just going to solder these wires in to the inputs of the frequency generator. So this is fairly straightforward. We have a positive and negative on the frequency generator. Here is the positive on the right side, so I'm going to grab that wire. Then we have the red on here of this power supply, and blue. In this case, the red is the positive. So I'm just going to twist these together for now so I don't mix them up later. And of course, the blue is the ground, and that'll go to the negative of the frequency generator. Next, I'm going to solder these wires together just so they're secure. So I'm going to get a little bit of the flux and wipe it on the connection. The flux acts as a lubricant of sorts, so the solder, once it's melted, will flow very easily into the wires. Then when I get my solder ready, and I have the sponge wet right here, so I'm just going to wipe it off so that I know it's clean. And I'm going to put the solder iron on one end of the wire to let it heat up and run into the wires. Then on the other side, I'm going to put the solder. So once it raises up to temperature, it should start flowing into it fairly quickly. You don't want to be breathing any of this flux in, so blow the smoke away from you. If it's taking forever, you can just touch it directly on top of it, let it run down, and then put the solder iron underneath it, and it'll suck the flux in. So that's all you need. Then just repeat on the other one as well. Double check that the wires are correct. So I have the red running into the positive, blue running into the negative. So once I've double checked that, I'm gonna wrap these up with some electrical tape just so they can't short. Next up, I'm gonna get the signal wire. These are very small gauge wires here. So I'm just gonna strip them. To strip them, I just cut the wire right here very carefully with a utility knife. I scraped away the insulation around them, and then I was able to split it apart. So then you have two wires. Then to strip the small wires, I just used some normal electrical wires. You just put it in here for the right gauge. So this is like probably 22 gauge, but 20 gauge should work. Then you just squeeze, and then you can pull off the insulation. Once you have these stripped, there are two options depending on how your amplifier is made. Sometimes there's an input right here called a high level input. You'll be able to plug these in directly to it. So then there's no modification needed, because it could take the higher voltage from the frequency generator and have no problems. It'll step it down to like less than a volt inside the amplifier, and it'll output normally. If there is not a high level input, you have to step down the voltage with some resistors. Otherwise, you will be outputting a much higher current to the speakers, and it will instantly fry the voice coil. So to do this, I'm going to wire in some resistors. So I'm going to go over quickly how to calculate what the resistors need to be. So to start off with, you need to know the voltage of what the frequency generator is outputting. So with the voltmeter, I'm going to set it to AC. So in this case, I'm going to push this in, and I'm going to leave it at the 20 just as a starting point and make sure it's set on voltage. So this is out. So being careful not to short these together, I'm going to touch one right here, and see what it's outputting. Okay, I have a slight change. Whenever I plugged in the power supply, it did not work. So for some reason it shorted out in the last few months. So I ended up having to splice into the 12 volt PC power supply. Anyways, to do this, I just took one of the wires out and spliced into it. Same for the ground. I had some grounds that I wasn't even using over here, so I was able to use one of those, and I put a switch in line right here going to the frequency generator. That way at least I'll be able to not have signal but still power the amp. So to continue where I left off, I have the frequency generator. It's connected to the PC power supply. I have my voltmeter. I have it set to AC, 20 volts, and voltage. No power going to the frequency generator. So I'm going to flip my switch to have power there. So now, first thing to do is check your voltage. So I'm reading 10.5 volts. Make sure I get a good connection. So at 10.3 volts, this voltage will change. This is on the lowest frequency possible. So if I move this all the way to the most, the frequency should drop because it can't output the same voltage at a much higher frequency. So it dropped to, looks like it's settling around 6.6 or so. It's fluctuating. Since I'm going to be having it around 25,000 hertz, which is the capacity of the speaker, it'll be roughly right here. So I'm just going to see what that is. Around 8 volts. So to use that voltage that you just got, it requires calculation. So this is just a circuit of how to drop the voltage. So whenever there's a resistor, there's always a voltage drop across the resistor, and the voltages add up to the total voltage across the circuit. I think that's Kirchhoff's voltage law. So my last frequency generator was at 11 volts, so I'm just going to use that as an example, though it will change once I put the 8 volts in. So I want the output to be less than 1 volt for the low level signal. If it's too big, again, this can't compensate for such a high voltage without changing the gain. I think the most, this one can go as low as 0.2 volts all the way to 6 volts, but I'm going to shoot for like around 0.8 volts or something less than 1 volt so I can control it. So I have my voltage that I measured out the frequency generator, and this has an input impedance of 10 kilo ohms. So that's the setting on your amp. You have to look that up to see what the input impedance is. So the total voltage is 0 around the circuit. The total resistance is R1 plus R2. One of these I know, R1 is 10,000 ohms. The current is equal to the total voltage divided by the total resistance. So it's voltage divided by R1 plus R2. Voltage 1 is equal to IR. This is just Ohm's law. So doing some calculations, V2 I want less than 1. So plugging in the equations, I end up with, coming down here, R2 is less than 1000 ohms or 1 kilo ohm. So you could use these equations to calculate what you have, but if you use the same resistors as I have, it'll probably be close enough. There's a big range that this can use. You know, this one uses 0.2 to 6 volts, so you could change the gain so the output to the speakers isn't so high that it'll fry them. So once you know which resistors to use, you will grab them. You identify them based off of these bands. You have to look this up online to see what these mean. The different colors mean different multipliers, but it's easy to tell what you're looking at. So one of these is the input resistor, or 10,000 ohms, and the other one is my 1,000. As a quick example, this is the 10,000 ohm resistor. So the color code goes from left to right. So we have first band and second band. Third band is the multiplier here. The fourth band is the tolerance. I know that these are all plus minus 5%. So that's easy. So that's the gold. But you read it as the brown is 1, the black is 0, and the orange means a multiplier of 1,000. So 10 times 1,000 or 10,000. And then the gold is plus minus 5. So I know this resistor is 10,000 ohms plus minus 5% of that value. You can also confirm this by hooking up to your multimeter. In this case it's 9.95. I know that this is in the 1,000 range, so that's 10,000, or 9.9 times 1,000. So that's 10,000 ohms. So once you have your resistors ready, it's time to connect them. So this is critical to how you connect them to get the proper voltage drop. So here is the 10,000 ohm resistor right here. This is a 1,000 ohm resistor. So using the numbers that I had, this comes down to a voltage drop of 0.72. So I need to put this across the resistor, and the voltage across that resistor will be 0.72. So here's the RCA cable. This is where the signal is typically carried. This is like a ground. It doesn't really matter because the signal goes both ways, but I'm gonna wire it in just to be consistent again. So this is the shielder. This is connected to the outside part, and the black one is connected to the center part. So I need the input impedance to be across the 10,000 one. So what I'm gonna do is connect the 10,000 ohm resistor, which is this one, to one of the sides. Again, there is no positive and negative on the output here because it's a symmetric curve. And since the voltage drop across this 1,000 ohm resistor is what I'm going for, 0.72 volts, this will give 0.72 volts into the amplifier. So I'm going to connect this return, the shield wire. So I have, if this is 0 potential, this is at the 8 volts. So I'm going to go 8. Then there's going to be a voltage drop across the 10,000 ohm resistor. That's going to be equal to 7.27 volts. And since the voltage drop across this one is just the difference between that and 8, we come up to the 0.72 volts again. So what I'm going to do now is put a small dab of solder just to hold these together permanently. So once you're done with this, I'm going to test it before I actually plug it into the amplifier. So I'm going to turn on the power supply. And the voltage drop across this should be that roughly 0.72. Looks like I'm coming in about 0.88. That's still fine. That's low enough for this amplifier. And I could also turn it up if I want to put some gain on it. With this correctly wired, I'm going to put some tape across all of these open parts so they don't short out on anything. You don't want any exposed metal. There's one last check before I plug this into the amplifier. I'm going to do a test on it. So this is what I'm calling the positive part, even though it doesn't matter. This is what I'm calling the negative part. I'm going to make sure this is set to the low range. So this is 0 to 2 volts. And I'm going to see what the voltage difference is. So I still have my 0.8. So you can see that a little clearer. So that's right where I need it. That way, when I plug this in, there won't send so much current to the speakers. So I'm just going to plug this in. I'm going to make sure it's on the same channel as my output. So my output's on the left channel, so I'm going to make sure and put this on the left So that's completing a circuit. So I'm gonna turn this off for now. Plug this in, and I'm just gonna turn my little switch off. So now I'm just gonna connect the jacks for the speaker output to the actual speaker. So now everything should be connected. So I'm going to quickly run through the circuit just to show that it's one completed circuit. So we have power from the wall. This is 120 volts AC. So if I plug this in, this will give power to the power supply. This will output through these wires. I have it connected right here. So this is not only powering the amplifier, it's also powering the frequency generator because I spliced into it through these wires right here, and I even put a little switch right here. So you can see those lead right here. This will output an AC signal right here, the 8-volt signal, depending on where this is. And I have the resistors right here. This will then follow along the RCA cable. This will input to here. Then the signal will be amplified. It'll output to the speaker output right here. This will go through all the wires, go through the used banana connections, and these will end up right here. And quick look inside, I only have this speaker connected, but you can see the wires go through here and end up at the speaker. So we have one completed circuit. Now that everything is connected, the one last thing to do is to turn the remote on. So amplifiers are typically turned on. Even though they have power, they can't actually turn on until there is a circuit completed right here. So you need to put the 12-volt supply into right here. This is just so the amplifier knows to turn on. So what I've done is I put a switch right here to some leads. So I'm just going to connect that right here. Now I'm going to turn the power supply on. So to test this, there's going to be a light right here that'll turn on. So I need to complete that circuit to the grounded remote right here. So I should turn this on and this little light should turn on. So that way I know the amplifier is turned on and can output. I'm going to turn that off for now, and this should turn off. So now I know everything is functional. One last thing to do is make sure you get actual sound out of the speaker. This is going to be very loud, so I'm going to put on some hearing protection. Here is the speaker right here. I'm just going to have it sitting on the power supply. I have two switches right here. One is for the amplifier, one is for the frequency generator. I'm going to turn it to the audible range, so as soon as I hear it, I can turn it off just to know it's functional. With this frequency generator, it outputs a signal in the audible range anyways before it powers up. Just to keep that in mind, if you want this to be completely silent when you turn it on, you will have to turn the frequency generator on before the amplifier. That way it's already in the ultrasonic range. But for a test, it doesn't matter. So what I'm going to do is turn the amplifier on first. I have my light on. Then I'm going to flip the switch. This will send power to the frequency generator, and this should start emitting a noise immediately. So it looks like that actually made the amplifier enter protection mode. Yep, it went into protection mode again. So I'm gonna stop and see if I can troubleshoot this. Okay, so this is about 2 months later. I had to give it up because it kept on turning on the protection mode for the amp. And I was not able to identify within the amp the problem. But what I did after a bunch of testing was finally just use a different power supply to power the frequency generator separate from the amplifier, and this solved the problem. So I just have a cheap battery tender and plugged it into the input of the frequency generator, and this was able to get rid of the problem. What was happening was I could hear the tone going through the capacitors here, even with the amp powered off. So I know there is some weird frequency interference going on because it was connected to the same power supply as the amp. So keep this in mind if it's not working. This is the first time to plug the frequency generator into the amplifier. The first time I had tested months ago, I had a separate power supply, but it had broken, so that's when I plugged into the power supply itself. So keep this in mind if it's not working or immediately going into protection mode, even without speakers connected to it, with just inputting the tone, then this is the issue. You're gonna have to use a separate power supply to power it. So now I'm gonna put this back together and continue. So here's everything put back together. So now it's time to do a real test run. I'm gonna modulate the tone right here starting low and then go high. There will be a slight delay for the amplifier to output the signal to the speakers, roughly 3 seconds. So I'm going to start it now and ramp up the signal until it gets just out of audible range. Now I'm going to bring it back down. So it looks like everything's good. Now I'm just going to put it inside of an enclosure of some sort. Now with everything hooked up, I'm going to do one last test just to make sure nothing will go loose while I was installing it. So I have the 12-volt power supply powering the frequency generator, and I have the AC voltage going into the PC power supply to power everything else. So now all I have to do is turn it on, and I should get audio out of these speakers. With everything working successful now, this is all there is to it. All I need to do is put the speakers wherever you want. You got plenty of wire, so now you're good to go. Thanks for watching.